My name is Carl Anthony, and I work in the automotive industry in Detroit. Sometimes that work encompasses future vehicle technology, and that's what we talk about here, for the most part anyway. This is AutoVision News Radio. Something I think is neat is when you discover that a particular company in automotive actually goes back farther than you thought. So they're doing things either before they got into automotive or on the side that are cool to hear about all these years later. A good example is Robert Boyer and Henry Ford. You can walk through their soybean laboratory in Greenfield Village in Dearborn. And the idea Henry Ford had was that plastics derived from soybeans could be more robust and sustainable than traditional metals. Another more recent example for me is the BMW Century book, authored by Tony Lowen. I mean, I knew that BMW made motorcycles, but I didn't realize until we featured that book on Automoblog just how far back their history with motorcycles went. This is similar to GKN Automotive. They have a long history that predates the automotive industry by well over a century. The combined letters GKN stand for Guest, Keen, and Nettlefolds. That combination of names originated in the early 20th century and went on until 1982, when it was shortened to GKN. The company's full history involves the railroad, the transition from iron to steel, and the leadership of Lady Charlotte Guest, who challenged conventional norms at a time regarding women in society. I'll leave a link in the show notes for more. Recently, I took the short drive from Detroit to Auburn Hills to meet with Ben DeLand, Director of Electrical Hardware Engineering at GKN Automotive. In this role, Ben leads the development of traction inverters and electronic control units for GKN's eDrive and all-wheel drive systems. Ben joined the business in 2015, holding already a variety of engineering roles focused on building GKN Automotive's electronics capabilities. He holds a degree in electrical engineering from the University of Michigan. During my time with Ben, I wanted to gain a better understanding of all-wheel drive systems. You will hear Ben and I rotate between two aspects. The first is the technical layout of an all-wheel drive system and the defining of some key terms, and then second, GKN's approach to sustainability and systems engineering, and the ever-present change in automotive.
From ADAS to electrification, this is AutoVision News Radio with Carl Anthony in Detroit, Michigan.
The automotive business is quite a bit younger, of course, starting in the 1950s. GKN took their knowledge of ironworks and steel and started developing side shafts and constant velocity joints for vehicles. With that, business became quite a dominant leader in side shafts and drive shaft technology. That was really how it all started with automotive, with torque transfer devices. And with torque transfer, GKN built on the knowledge and stepped into torque management devices. So that would be your all-wheel drive, stability control of the driveline, traction control of the driveline type devices that we still see in the market today. From torque transfer, learning about the vehicle integration and stability and calibration at the vehicle level, it allowed us to then step into torque generation products. So electric drivetrains, full eDrive systems. So really, we built upon that knowledge from torque transfer, torque management, to torque generation, and we're one of the only companies that can provide that full solution from the generation of power in the powertrain fully out to the wheels through the driveline.
There were three key terms that Ben mentioned: torque transfer, torque management, and torque generation. And since anything with the word torque in it sounds awesome, I asked Ben to take us through what each of them mean.
Torque transfer really means taking the power, the torque that's generated from the powertrain, whether that's a traditional powertrain or electric powertrain, and getting it out to the wheels with a side shaft, and doing that as efficiently and quietly as possible. Torque management, we're talking a bit more active management rather than just transferring from point A to B. In between, you can modulate that or split that torque to benefit the stability and traction of the vehicle. So that's how we would think of a traditional all-wheel drive system working. And by torque generation, I mean being the powertrain for the vehicle. And GKN is not in the engines and transmission business or traditional transmission business, but we are in the electric powertrain business. So we have the ability to design and produce what we call 3-in-1 systems for electric drive systems. So that would be an inverter, a traction motor, and a gearbox, which is replacing the traditional combustion engine and transmission in the vehicle.
At the time of this broadcast, almost 50% of new cars worldwide feature GKN Automotive systems and solutions. Likewise, GKN supplies 90% of the world's automotive OEMs with powertrains and electric drive systems.
I mentioned that GKN Automotive entered the market with CVJs and side shafts, and we continue to be the dominant player in that arena. So that is a dominant product, a dominant technology for us that we continue to innovate upon for better efficiency, transitioning those side shafts and joints toward the new needs of electric vehicles as the market is transitioning into that segment. We're talking higher torques, different torque profiles with electric vehicles as well, often shorter side shafts with higher angles because of the differences in the electric powertrain versus traditional combustion engine and transmissions. So there's a lot of changes ongoing there as well, and a lot of innovation. So that's been the backbone of our business. And finally, we are electric powertrain partners for our customers. So this is something we've been doing for over 20 years. We're one of the early players with electric powertrains. So some of the early EVs and hybrid vehicles have GKN systems in them. So we have the ability to produce components for customers, just gearboxes, just traction motors, or just inverters. 2-in-1 systems, if that's what our customers are pursuing, typically that would be the traction motor and gearbox, up to full 3-in-1 systems, inverter, traction motor, and gearbox all together.
And we return now to some key terms: inverter, traction motor, and gearbox. I asked Ben to help me get my mind around this idea of a 3-in-1 system.
Each have specific goals to them to work together in the system. The battery in the electric vehicle is operating at a DC voltage that is connected directly to the inverter. The job of the inverter is to invert that DC voltage and make it an AC waveform output that drives the traction motor. The traction motor is taking the AC waveform from the inverter and internally creating an electromagnetic field that generates torque in the rotor of the motor. The output of the motor is connected to the gearbox. The gearbox is needed because the traction motor itself is unable to provide sufficient torque to the vehicle. So the gearbox is providing a gear reduction off of the rotor of the traction motor to provide higher torque levels.
As of the fall of 2023, GKN employs over 25,000 people, operates in 19 countries, and has nearly 50 manufacturing sites globally. In 2021, GKN sold over 500,000 all-wheel drive systems and over 230,000 e-drive systems. The company estimates that will ultimately help reduce vehicle emissions by more than 250,000 tons of CO2 annually. 2021 was also the same year GKN created its sustainability strategy, which aligns to 6 of the 17 Sustainable Development Goals outlined by the United Nations. And I quote the UN now. The 17 Sustainable Development Goals are an urgent call for action by all countries, developed and developing, in a global partnership. They recognize that ending poverty and other deprivations must go hand in hand with strategies that improve health and education, reduce inequality, and spur economic growth, all while tackling climate change and working to preserve our oceans and forests. GKN's sustainability strategy includes measures for climate action and responsible sourcing. As Ben describes, sustainability is a core aspect of GKN's philosophy, and as such, they have modeled their engineering processes accordingly.
The mission statement of GKN Automotive is to drive a more sustainable world. So efficiency is the key aspect for designing these systems for us. It's what the market desires. It's the best solution for the climate going forward. It's what in the future will separate electric vehicles from traditional powertrains, and that they can be much more sustainable. So the key design aspects for us are achieving the highest efficiency, the best performance at the best cost possible for our customers. The process for achieving that is within GKN a full system approach. We've transformed our engineering organization to be fully system oriented. If you approach efficiency or performance with a mechanical engineering team focused on a gearbox, an electrical hardware team focused on an inverter, and software doing their own thing to put it all together, you're going to end up with a very mismatched product. So systems engineering focus for GKN is critical for achieving our goals in efficiency, best cost, best performance. In terms of the product, how that is all coming together, we start with our stated goals and our technology roadmap. What's important for GKN's brand in terms of the market that we want to penetrate, those goals that I had just mentioned there. We work to translate that into product features. If we look at efficiency, we are looking at different motor technologies. We're looking at how the motor is interfacing with the inverter, reducing any losses that we can from resistive losses in the copper, the efficiency with how the motor is assembled. And a huge aspect of this is controls, how that AC waveform in traction motors is created, when and how to apply torque in various situations. The automotive world is moving extremely quickly to sophisticated controls in electric vehicles that enable these high efficiency, high performance vehicles to occur.
In addition to efficiency, there are 3 areas of focus when GKN is working with its customers: traction, stability, and agility.
Especially with all-wheel drive, we look at 3 key performance levers that can be pulled for kind of 2 different trade-offs. One is traction, so wheel slip, managing that. The second would be stability, correcting for understeer and oversteer, safety events, quick lane changes, things like that. And the third is agility. Agility means fast cornering, performance driving, enabling those types of things. Depending on where our customers want to be with traction and stability and agility, we can offer them a wide range of different products at different trade-offs. And the trade-offs are, of course, cost, and the second being packaging. We need to have this wide range of product offerings, starting with open differentials, enabling the 2 wheels on the axle to operate at different speeds, to kind of mid-range devices of limited slip differentials, which are providing some traction and stability without the agility, into torque vectoring type devices where you have 2 clutches on the axle to independently provide torque to each wheel on the axle to allow that fast cornering and performance driving that's demanded, all the way up to full e-drive systems that are providing 2 motors on the same axle, providing that same torque vectoring possibility, but instead of being a hang-on system, it's a torque generation system. So accomplishing the same thing, but generating the torque itself. As you step through those, you can feel the packaging and the cost differences from an open differential up to a dual motor e-drive system. So for us, the key is really in understanding understanding the final vehicle that's being built and what the customer is really after, and attacking that with the right product.
I began my automotive career in 2009 at Sioux Falls Ford in Sioux Falls, South Dakota. That was back when I didn't have any gray in my facial hair. We were, as you can imagine, in that area of the U.S., a high-volume dealership for trucks, especially new F-150s. And back then, it was the 5.4 V8, which eventually gave way to the 5-liter V8 and then the 3.5 EcoBoost in 2011. As I grew in my understanding of the automotive business and trucks in particular, I learned that a limited slip differential was a must-have feature for many truck buyers. I asked Ben to give us a more in-depth look at limited slip differentials.
Limited slip differentials are devices that compensate for differences in speed or torque at the two wheels on the same axle and provide more torque to the wheel with better traction. That can be done mechanically with some clutch plates in the limited slip differential, which is very good for packaging, but lower performance, or it can be done electronically. So electronically means we have a clutch that is operated by an actuator, typically a motor, with a piece of electronics that is controlling it, taking inputs from the vehicle, wheel speed, steering wheel position, throttle position, these sensor inputs that are coming in from the vehicle to take decisions on how to provide torque to each of the two wheels on the axle. And torque vectoring devices allow you to independently control torque to each wheel on the same axle. This is always done electronically, so with an electronic control unit connected to it, you have two wet plate clutches that are compressed with actuators, either a single actuator with hydraulics and valve controls between the two, or two independent motors controlling each clutch to get that high agility, high stability, high traction performance. Stepping away from all-wheel drive, you get into the e-drive products. We are making full 3-in-1 systems as defined with the inverter, traction motor, and gearbox that's doing the torque generation. At its most basic level, you would have an open differential inside a electric drivetrain sitting at one of the axles. Then you can make those same steps that we just made with the all-wheel drive products and integrate them into the e-drive products. So going from an open differential to limited slip differentials in your electric powertrain up to torque vectoring in your electric powertrain, which may be done with two clutches or can be done with two motors independently controlling the wheels there. So you can see the synergies that we have between all-wheel drive and our e-powertrain units, where the functionality from all-wheel drive really is integrated into the e-drive units. A lot of those controls mechanisms for lateral acceleration, managing the stability and traction and agility of the vehicle that was learned in our all-wheel drive systems is very directly applicable to e-drive in the same way.
In my work for Automoblog and AutoVision News, I spend a fair amount of time going through press releases and product sheets. I actually enjoy doing this. But you do come across a lot of phrases and terms, or if you're looking at it from an SEO perspective, keywords, and sometimes they can all kind of get jumbled together, and they're just terms on the PDF without any real meaning. And so I've always tried to define those key terms when I get the opportunity to, and all-wheel drive is one such term. It's not new, we see it written frequently in automotive, but I was curious to get Ben's perspective on how an all-wheel drive system for a gasoline vehicle compares to an EV.
With a combustion engine vehicle, an all-wheel drive system needs to have a method of sending torque to the other axle. This is done with typically a prop shaft that runs longitudinally from the torque generating axle out to the axle that doesn't have torque generation in it. That is the key difference, because with electric vehicles, the way of accomplishing all-wheel drive is to just add another electric drive unit to the other axle. The difference at the axle itself is quite less. The torque profiles may look different. The use cases might look slightly different, but fundamentally, you're talking about the same actions there. But the prop shaft that's running longitudinally is quite a big difference. That's providing drag on the vehicle, so it's less efficient. And for combustion engines has led to different products called disconnect systems. Disconnect systems are used to make the vehicle more efficient. In the case of combustion engines, where you have a prop shaft running longitudinally from the front axle to the rear axle, if you are in situations where all-wheel drive is not needed for traction or stability, you don't want to have that extra drag loss from the prop shaft. So a disconnect system is a clutch-driven system with an actuator that opens up the transmission or TKS output from the prop shaft to reduce the drag and increase the efficiency of the vehicle. It's the case then that GKN Automotive for combustion engine vehicles has a lot of disconnect devices that's providing that functionality. Now, disconnects are also very important for electric powertrains. The drag situation is a bit different. The drag in electric powertrains is coming from the traction motor itself when it's a permanent magnet motor. With an electric powertrain on an axle, if it is not generating torque and it's a permanent magnet motor, it is causing drag. The driveline from the wheels will spin the side shaft. The side shaft is going to spin the motor, and the motor spinning through the stator is creating a magnetic field and causing drag on the system. So in that case, it's beneficial to integrate a disconnect system into the electric powertrain to ensure that you have highest efficiency when you're not in torque generating mode.
After a good technical discussion, I felt it was fitting to ask Ben what his favorite car is and why.
My favorite car. So I can tell you what I drive now, which I really like, which is a BMW 328i station wagon. I like station wagons.
Yeah.
Station wagons have low center of gravity, excellent handling, maneuverability, and they're also offering practicality. I have 3 young children. 2 of them can get in the station wagon with all of their accoutrements. So I think the love for station wagons came after I joined GKN Automotive. I've been with GKN Automotive for 8 years. I think before that, probably station wagons had the stereotypical American point of view that they're kind of lame. But after joining GKN Automotive and understanding drive dynamics a bit better, handling a bit better, and what all-wheel drive systems can do for your vehicle, I saw the engineering benefits of what a station wagon can offer, or let's say a sedan vehicle can offer. But station wagons offer the additional level of practicality that's needed for my life.
To learn more about GKN and the 17 Sustainable Development Goals from the United Nations, see the link in the show notes. AutoVision News Radio is available on Spotify, Apple Podcasts, Podbean, and more. In Auburn Hills, Michigan, alongside Ben DeLand, I'm Carl Anthony, AutoVision News Radio.